In this problem, you are asked to write an equation for the relationship between the pressure and the depth. Okay, so pressure is going to be your dependent variable and depth is going to be your independent variable. So when you graph, your pressure is going to go along the y-axis and your depth is going to go along the x-axis. Okay, so reading the question, it says, at the surface of the ocean, the water pressure is the same as the air pressure above the water, okay, which is 15 lb per inch squared. Below the surface, the water pressure increases by 4.34 lb per inch squared for every 10 feet in descent. So technically this 15 is giving you the y-intercept. So it's actually the b is 15. And the water pressure is given as 4.34 lb per inch squared. Is kind of giving you, because it's for every 10 feet, it's kind of giving you the slope 0.434 lb per inch squared. So we know when you write an equation of a line, y equals mx plus b, and in this case my y is p and my x is d, but I think they want you to keep as d, yes, depth as d. So it's p is equal to 0.434 d plus 15. So this is the equation that's representing the picture which would go here. P is equal to 0.434 d plus 15. So with this information, first, we know by looking at this is a linear function. So P will be along the y-axis and your depth will be along the x-axis. Now let me graph this here just so that I can see what I'm going to see. So I would put 0.43, and in my graphing calculator I will have to use x instead of d because that's how it's built. Okay, plus 15. Now I'll keep my window. I don't need to know what is in the negative direction, so I'm going to keep that 0, and this also 0, y minimum and x minimum. Now if you look at the graphs here, all the graphs have a maximum x value of 5 and a maximum y value of 20. So I would change my x max to probably 5 so that I can connect to what I'm seeing here, right? And my y max to 20. So hit graph, and this is the function that we see. So from here we can identify that the answer is going to be, if I connect to what I'm seeing here, the answer is my second graph, which is this one. Okay, now here keep in mind, with this information I need to answer 2 more questions. So I know from this graph this point is my y-intercept. Okay, and yes, this p is along the y-axis and d is along the depth is along the x-axis. This is my independent variable, and this is my dependent variable. Okay, so let me go back to these 2 questions that I have to answer. So with this graph, so the first question is asking, what does the slope of the graph represent? So in here, the slope of the graph, it is a positive graph, like the slope is increasing, right? The line has an increasing slope, so this is positive, right? So the slope is representing the increase in pressure per foot of descent. So this is the correct choice for A, for this part of the question. That's what the slope is representing. Now, what does the p-intercept of the graph represents? The p-intercept is giving you the pressure at the surface, which is this point. And it's given clearly that the pressure at the surface is 15, right? So that is the P-intercept. So this would be the correct choice for the second part of C. Okay. And then the last part is asking at what depth is the pressure 190 lb per inch square. So I have the equation P is equal to 0.434 D plus 15. Now what is given is 190 for the P, 0.434 D plus 15. So I need to solve it. Subtract the 15 to the side. So I have 190 minus 15, which would be 175, right? 175 is equal to 0.434 D. So to get D by itself, I have to divide by 0.434, 0.434. Therefore, my D would be equal to divided by 0.434. So 403. Did I do that right? 403. Yes, 403.22. And I think because it's saying round your answer to the nearest foot, right? So I can say D is approximately equal to 403 feet. T minus 15 divided by 0.44. Okay.